So here's an example of using the t-statistic to analyze some experimental data. The experiment was 24 individuals are asked to identify which of a pair of speakers was taller just by the sound of their voice. So they took 100 pairs of speakers of the same gender, some male, some female, and then they were asked to repeat a phrase. I don't know what the phrase was. The two individuals each would speak the same phrase, and then the individuals involved in the experiment were trying to determine which of them was taller just by the sound of their voice. So you imagine the taller people maybe have a deeper voice, shorter people maybe have a squeakier voice, or whatever we might think. The size of a person affects the quality of their voice. It may not be true generally, but it might be true on average that taller people have deeper voices or some structure in the way their vocal cords work. Who knows that you can actually tell by how they talk whether they're short or tall. So they did that with 100 pairs, and then we recorded for each person, so this is the result for each individual, how many of the pairs they identified correctly. Now if you had no ability to tell the height of a person from the sound of their voice and you had to pick something, you would average 50 correct because there's 100, so half the time you'd be right, half the time you'd be wrong because you'd just be doing it by pure random selection. So anything above 50 seems to give some evidence that maybe there's some ability to determine height from voice sound. And those below 50 would say we got it backwards. There's an inverse relationship. We think they're taller but they're actually shorter. That could happen in some way. But most of what we're seeing there is probably just random variation, because you can't be that 100% accurate. Even if you were somewhat accurate at predicting height from voice, you're not going to be 100% accurate. And so you're going to see some variation as you get some of them wrong and some of them right. You're just probably a little bit maybe better on average than 50%. So those are the numbers. So the first person got 43 right, the second one got 55 right, and 52, and then 62, and so on. So here's the result of the sixth person, 47 right, and so on. And most of those numbers appear to be over 50, not all of them. So that would lead you to believe that maybe there's some ability to predict height from voice sound, but we're going to have to use statistics to see if that pattern there that we see in the values is strong enough that it can't happen just purely randomly. It might be. It's hard to tell. If you gave them the situation and you just let them just guess each time, could you get those kinds of numbers? Or is there some skill that's shown by these numbers being somewhat above 50 in this particular pattern of 24 values? So we asked the question, do people tend to do better than guessing on average in guessing height from voice? So better than 50 on average in this experiment. You should average 50 if you're just guessing. The assumptions, we need simple random sampling and we need normal distributions of values. So first we'll assume the individuals were chosen by simple random sampling. So we didn't pick individuals that were maybe voice coaches or something like that. We're just talking about people in general. Can they tell height from voice characteristics? Do people do better on average? So let's assume the individuals chosen for the experiment were chosen by simple random sample. They had no special ear training. You could maybe train yourself to really figure that out. If you, maybe not, I don't know. Second thing, we need normal distribution, so let's make a stem plot to see if normality is indicated. So we don't have the population to look at, all we have is the data, so we look at the data set, we make a stem plot of the data set. If that stem plot looks like it's approximately normally distributed, then we'll say the population conceivably could be normally distributed, and we'll use that as evidence that we can continue on and use the t-distribution, which requires something like a normal distribution to work properly. So we'll go ahead and make that, and then we'll continue on with the process. We can do two things. We can make a confidence interval and we can do hypothesis testing. Let's see what happens in just a minute.